Thank you. Thank you, Carl. You basically gave me my introduction because data is really what I'm here to talk about. And I'm actually very passionate about this subject. I think years ago, I was interested in EDI when people didn't even care about what it meant. And here I have we'll do a very, very quick historic background. Everybody knows about the Rosetta Stone. It wasn't until this was found in about 1800 by Napoleon that they could actually decipher hieroglyphics by comparing it to two other languages that were used at that time. And the point is that a very simple concept of the internet, a set of globally interconnected computers which enable everyone to quickly access data and programs from any site, comes only from 1962. But 4 years later, three different groups came up with essentially what we are here celebrating years later. And essentially, this comes down to standards that we all agree on. And we don't have to agree on one standard, and that's what big data provides us at this point. There are many silos of information in structured query language. And what we're proposing and what we think will be a huge boost to this industry is this confluence of 3D online, video gaming, AR, VR, basically all of the technology for display technology, big data, and telecommunications. Because what Carl was mentioning before is that we need to connect people, machines, objects, and vehicles. And I'm convinced that if we come together with a standard in big data, a meta standard that will allow us to import these different standards, which Anand will talk to us about, we will be on this new revolution. I'm going to show a very short video of what this might look like. This is a refinery which we imported the data, and this entire structure was created in 1 week, not by redrawing the data, but actually just displaying it using Unity, which is a standard video game technology. All of the objects in this refinery would be stored in the big data repository, but then, again, thanks Carl, all of the workers are geolocated in real time so that people, supervisors, whoever needs to can locate them. And then what we see here is a simulation of a problem with a piece of equipment, which of course we're pulling from the database of the original supplier of that piece of equipment. We connect with the worker. We know who they are, that they're qualified, that they're authorized, et cetera, and we dispatch that person to the problem. This is the point of view of the supervisor as the person walks towards the problem. We open a telepresence window. This is where telecom, again, is important. That person pulls from an inventory of parts, which of course the suppliers have graciously provided because it's in their interest, and the problem is solved. And what we're talking about is none other than just agreeing on a meta standard in big data that can import all of this information. And now I leave you with Anand.
Thanks, Jim. I'm working with Jim to help him on the big data stuff. I'm doing big data strategy consulting, helping a lot of companies sort out their big data strategy. So augmented reality and virtual reality are great spaces. Great progress is being made, and when we are finally there, it would be my holographic image here who would have been talking to you. So we have a lot of ground to cover, which is exciting. But the whole ecosystem is coming in place with key players, and we can expect a lot of exciting innovation in this area. And the one collaborative work environments that Jim is proposing is really very exciting, and it will create a lot of opportunities for a lot of us. So this is, in general, the projection. In terms of engineering, in 2025, about $4.7 billion worth of market. Education, $0.7 billion, and we have, so this is going to be a very active space, and the big promise is going to be essentially collaborate with anyone, anytime, anywhere, and it will be possible in terms of VR, AR, telepresence, all these technologies being together. Here are some examples of collaborative work environments that are possible through virtual reality and augmented reality, and we all are familiar with it, from Star Wars time when you have teleportation and things like that. So that at least conceptually, these ideas have been there with us for a long time, and we all know by our own experience, we can't be in two places at the same time. So time and space constraints limits what we can accomplish. So if these technologies make it easier to collaborate, we can accomplish much bigger things. So collaborative work environments have a lot of different components. We have video game technologies that we can apply, AR, VR, telepresence technologies, and software as a service and 3D modeling technologies, and they all can be tied together using big data repositories. It's essentially like a big data lake where you can keep structured, unstructured images, video, data in a consistent, reliable manner. And so here is one of the use cases. This is like aircraft maintenance. And aircraft maintenance, in aircraft MRO space, there are about 600 companies are involved. And aircraft maintenance, it's a costly procedure because aircraft, if it is down, then you have an impact to the bottom line for the airline industry. And sometimes you do not know when you will need it. Sometimes you can schedule it using, if you have all the information available in one place, it can simplify or make it more efficient. So in this particular image, the important thing is that a person is doing aircraft maintenance, but he is being guided by a remote center using virtual reality and augmented reality. So the person, and there are a lot of videos on YouTube about this kind of stuff now. The person is a qualified technician who is working on the ground, but he may not have the full information or may need some additional data. So the person at the control center get to see what exactly the on-site person is seeing, and he can guide them using voice connection. And also the maintenance procedure information can be holographically projected on the real world objects so that person can perform a complex procedure with confidence. It is very exciting, and similar things are happening in the medical space also, where doctors are performing remote surgeries. So it is the extension of it to some very important real world complex procedures. Another big project thing is the large constructions, and these are big buildings and oil and gas refineries. So right now, building information modeling is becoming a standard. Some of the regulatory agencies are requiring that your project is submitted in the BIM format before they will approve it. But it can also be evolved to incorporate additional data sets and put it into a scalable big data repository so that you can have all the relevant information, all the latest version of information, as well as the state information of what we will say like full life cycle of the project. So you will have everything in one place, and that will ease, because most of the confusion comes because the information is not available to the right person at the right time, or information is outdated. So an efficient organization in today's world is one where people in that organization are acting upon the information. They should not be looking for information. Looking for information, and that is the goal of collaborative work environments, that information is available, trustworthy, reliable, and latest to anyone who needs to know. So they should not be wasting time looking for it. They should be acting upon it. And that will create huge efficiencies, and especially some of the oil and gas projects are hundreds of millions of dollars, and any efficiencies there would add up very quickly. So coming back to aircraft maintenance, I essentially have described some of these things to you, but using machine learning and predictive analytics algorithms, you can find the best time and place and maintenance company to perform the maintenance. You will require access to the flight route info, maintenance history, part availability, and location capacities data set. So when you keep all the data in one repository, it creates synergies for users. And there was recently an article in Harvard Business Review about this aircraft maintenance topic that I have referred here. Then in the military is using a lot of these technologies. Military is using very expensive technologies for flight simulation and battlefield simulation. Using audio, AR and VR, you get much better simulations at much lower cost, and that's why this space is projected to see more and more use of AR and VR technologies, even though the total spend will go much lower, but still there will be a lot of application there. Then traditional databases versus big data. Traditional databases have size limitations, and after a certain size, you have to do a forklift upgrade, and nowadays we are dealing with petabytes of data, so traditional databases don't scale. So the big data technologies are able to scale because you can provide incremental capacity by adding relatively inexpensive hardware, and at the same time they are able to deal with the velocity, variety, and volume of data that is being generated. And there are already systems in place which deals with 1 billion events per second. So there is, in terms of size and capacity and latency, the huge capability is there, and we just have to leverage it for the big industrial projects. This is a typical big data system architecture. You require different components in it, and the infrastructure is your physical infrastructure. You need to ingest the data from various data sources, and then you need some message queues to store data for in-between times, and then you can apply a lot of different algorithms to it, and also use it to support various applications in terms of management and monitoring, workflow, scheduling, and it is being used in several application areas. What we are proposing here is that we have a concept of a smart object, essentially a high-level definition of what an object does, and for semi and for structured and semi-structured data, a XML or JSON, JavaScript object notation-based specification works quite well. We can just compile into binary JSON and store it in the database as it is, and also from those we can automatically generate the APIs, which are the access function, like for create, read, update, delete, and also the REST API, so that it's easier to provide the provisioning systems for these. So from this kind of a structure, it becomes easier to build huge systems, because everything is a smart object, and once you specify at high level what its schema is and how you want it to behave, what are the access control lists for it, as well as role-based access control mechanism, you can generate the code automatically, and that allows you to build a very highly scalable system relatively inexpensively. And when you have a system like this, it allows you to do collaboration across industries, across geographic constraints, and across various dimensions. So this is what I just mentioned, and you can use different programming languages bindings to create these interfaces, which allows you different people, if they prefer different languages, they can get the APIs for that. And you can, there are certain web interfaces you need for administering such a system, because it's across industry, and companies can come and self-subscribe to it, and they can do different financial as well as project management kind aspects integrated into it, as well as the supply chain logistics. So the concept is to build ERP and MRP system which provide all across the stuff. And then there are special ways of doing what kind of access control you need, security and all, which are very well understood. And those are just some definition. Key thing is we should be able to keep audit logs of everything and encrypt sensitive data, and some regulations that we need to comply to. So, and also an IoT interface to it, so that devices can report their state in a time series data. And that's overall general thing.
Yeah. Thank you very much, Anand. Also, if there's anybody in big data, video games, or telecom that's interested in the project, please talk to me, because we're looking for guru talent. Thank you.
Great. Thank you, Jim. Thank you, Anand.